So we're starting Unit 5, and Lesson 1 is on the primary trigonometric ratios. This would be review, especially this lesson. The entire unit is a lot of review from grade 10 academic math. There will be a few new little things, but hopefully a lot of this will be familiar. So trigonometry as a subject grew from simple geometric concepts. Two basic ideas that I'm just going to kind of mention is one is the Pythagorean theorem. So we'll need to use that a few times through this unit. And I think you'll remember that the hypotenuse is the longest side of a right triangle opposite the 90-degree corner. And this is a formula that you might see used. Another might be c squared equals a squared plus b squared. That might be a little bit more familiar, where this side C is the hypotenuse and it's the one that has to go on its own. The two legs are the ones that you would add up in the formula. So we will review that a little bit. Similar triangle theorem, another basic concept that you learn in grade 10 math, where we look at this little symbol means similar to. So triangle ABC is similar to triangle PQR. And what that means, it's written in a certain order, and the order does matter. It's trying to tell you that angle A and angle P are actually the same measurement. So if we mark them with little symbols, angle A and angle P are the same, and then B and Q are the same. So these would be the same size measurement. So I might mark those with a different symbol. And then C and R would be the same size measurement. So these are similar triangles. One is just larger than the other. You might remember doing questions where maybe one side would be unknown. All of the angles are always the same measurement because they have to add up to 180, but the sides are proportional. So for example, if one of these sides is unknown, we can do something like set this up as ratios, like this side over this side is the same ratio as maybe this side over this side, and we can solve for the unknown if that's familiar to you. So the angles are all equal to each other because the triangle, no matter how big it is, still has to add up to 180. But this is the kind of thing you might remember. If we take ratios of sides, you're able to just use two of those at a time, cross multiply, and find a missing side. Other students just understand that, you know, if this triangle's magnified and it's maybe 4 times bigger, then all of the side lengths would be 4 times larger. Last year, we did talk about the primary trig ratios. So given any triangle, do you remember sine, theta? And theta is just a symbol for an angle. It could be any symbol, it doesn't matter. Cos theta, tan theta, opposite over hypotenuse, adjacent over hypotenuse. I think if anything you might remember, it might be SOHCAHTOA, which is exactly what we're showing up here. Sine is the opposite over the hypotenuse. So sine is the opposite over the hypotenuse. Cosine is adjacent over hypotenuse, and tangent ratio is opposite over adjacent. So remember one important thing with trigonometric ratios. If this is the marked angle, that's called the angle of reference. The way I always teach this is I say, imagine that you're standing at the angle of reference. Then across from you would be the opposite side, and beside you is the adjacent, and the hypotenuse is always across from the 90-degree angle. So just remember that it depends on where you're standing. The opposite side is always going to be across from you. So just a little review, because this is supposed to be review. Example 1, write the ratios for sine, cos, and tangent for the given triangle. So since this angle here is marked with a theta symbol, we could call this angle A, we could call this angle theta. This means that you'd be standing up here though. So this is your angle of reference because it's the one that matters for this question. So angle of reference. So when I look and I'm standing from up here, this 3 would be my opposite. The 4 would be my adjacent. And this side over here would be my hypotenuse. So if we need to write out sine, cos, and tan for this triangle, if I'm standing up here, I do need to know what the hypotenuse is. So one way to do that is to use the Pythagorean theorem. So we're able to find that the hypotenuse has a length of 5 units. This doesn't have centimeters or anything on it, so just 5 units. If I want to write the ratios, so sine theta, or I could say sine A, it doesn't matter what symbol I use, it's representing an angle that I don't know. Sine theta is the opposite over the hypotenuse. And I know when I'm standing up here at the top of the triangle, my opposite is 3 and my hypotenuse is 5. So this is just how you would write the ratio. The cosine of theta, or cosine of A, we would do adjacent over hypotenuse. And if I'm standing up here, the adjacent is beside me, so that's 4 over 5 is the hypotenuse. And then the tangent of theta, if I'm standing up here, the opposite over the adjacent is tangent. So that would be 3 over 4. Example 2, Anisha stands 14 meters to one side of the top of Kakabeka Falls. Her line of sight to the base of the falls forms a 70-degree angle down from the horizontal. What is the height of the falls? So it's nice when you get a diagram for this. We do have an angle that's marked up here in the corner. Please know that, imagine like, okay, I'm standing up here. It helps you understand what side is called what. So when I'm standing up here, across from me, this, I know it's marked with an H, which might be confusing. H for height, not hypotenuse. This would be my opposite, and this would be my adjacent. So I would have opposite and adjacent when I'm thinking about my SOHCAHTOA. So I usually write it like this, ka toa. If I'm using opposite and adjacent for this question, then I know for sure I need to use the tangent ratio. So the tangent of an angle, we could call it any symbol. The tangent of theta is the opposite over the adjacent, and that's just the formula. So we know the angle is 70 degrees. Remember that the angle always goes beside the little ratio word. My opposite is h because I don't know what it is right now, and my adjacent is 14. So if I wanted to solve for h, really all I need to do is cross multiply. So right away I'm going to get the answer for h. Not 70 times 14, tan 70 times 14 is 38.46. So therefore the height of the falls is 38.46 meters. Example 3, another one here, just to practice knowing which ratio to use. Jamie's kite string is 35 meters long. It makes an angle of 50 degrees with the ground. Let x be the horizontal distance in meters to the kite. What is the horizontal distance between the kite and Jamie? Okay, so let's say Jamie's standing over here. And this is the angle that is marked, so that's our angle of reference. This side, then we look at what the sides are called. If you're standing here, this is your adjacent, and this is your hypotenuse. So I know that whatever I use, I'm going to use adjacent and hypotenuse. So that is the cosine ratio. So the cosine of any angle is the adjacent over the hypotenuse. And so if we fill in what we know, the cosine of 50 degrees, because that's where the angle would go, these are sides. Remember that these are sides. Adjacent over hypotenuse are side lengths. The 50 degrees would never go on this side. So the adjacent in this case is x and the hypotenuse is 35. So very similar to the last one. In order to solve this problem, we can just find the cosine of 50 times 35, and it's easy enough just to let your calculator do that. Cos 50 times 35 is 22.5. Remember that you need to be in degrees when you're working in trigonometry, so you double check your calculator that the mode is set to degrees. You might have a little d or a little DEG on your screen. So therefore, the horizontal distance is 22.5 meters. Okay, example 4. In the Great Pyramid of Giza, there is a 115-meter long passage that leads from the northern face to an interior chamber. If the chamber is 50 meters below the opening of the passage, find the angle of depression. Okay, a few things in this one. Now we're actually looking to find an angle. So this is the only other thing that you need to know about trigonometric ratios. If we're trying to find this angle, we have the opposite side over here. And this is our hypotenuse side. So imagine that you're here, and this is the angle that we're trying to find. So opposite over hypotenuse, I know that that's the sine ratio. And we're trying to find the angle of depression. So angle of depression, I'm not sure if you remember, angle of depression is from the horizontal down. So this is our angle of depression from the horizontal down. The angle of elevation is always from the horizontal up. So I'm not sure if you remember that, but angle of depression. So we're just trying to find the angle here. We know that it's sine, so we do sine theta, because we have opposite and hypotenuse. So if I think of SOHCAHTOA, that is sine. And so opposite, sine is opposite over hypotenuse. And we fill in what we know. So this time we don't actually know the angle. You could say sine A or sine B or sine theta, it doesn't matter. Our opposite though is 50 and our hypotenuse is 115. So I'm not sure, a lot of students will get stuck at this point because they're not quite sure what to do. We would probably, I don't know, a lot of students could just type this right into their calculator how it is. But sometimes you like to see when you divide that right-hand side, I get 0.4348. And remember that we're using 4 decimal places usually in trigonometry, so we get a nice accurate answer. So the angle theta, this is how we usually write it. It's the inverse sine of 0.4348. And so you have to push second function or shift on your calculator in order to find an angle. So anytime you're going to be looking for an angle, when you don't know the angle, this is the only time we push second function or shift on your calculator. So you should be able to see this sine, inverse sine or inverse cosine, or the inverse of tangent on your calculator when you push second function sine or second function cos or shift tan. Depending on your calculator, it's either the top left button usually is second function or shift. So when we do that, hopefully you can practice this and figure it out and try and remember that we would get 26 degrees. So therefore the angle of depression of the passage is 26 degrees.